Okay, so today we're going to start talking about types of chemical reactions. So there are several ways to classify chemical reactions. The classification scheme described in this section provides an introduction to the 5 basic types of reactions: combination, decomposition, single replacement, double replacement, and combustion. And today we're going to focus on combination and decomposition reactions. Okay, so combination reactions. So in a combination reaction, also known as a synthesis reaction, 2 or more substances combine to form a new compound. So this type of reaction is represented by the following general equation. A plus X will produce AX. A and X can be elements or compounds, and AX is a compound. So for the elements, don't forget our diatomic molecules. Which we know are the halogens F2, Cl2, Br2, and I2, along with hydrogen, nitrogen, and oxygen. Now we see in a combination reaction, we have 2 reactants and 1 product. Okay, so reactions of elements with sulfur, with oxygen and sulfur. So almost all metals react with oxygen to form oxides. So the group 1 metals form oxides with the formula M2O. So for example, say we had lithium, which is in group 1, plus O2, that would produce Li2O. So the Li would take the place of the M. Now just make sure we balance these. So how do we do that? We see we have 2 lithiums on the right, so we need 2 on the left. But now we have 2 oxygens on the left, only 1 on the right. So let's put a 2 here for the Li. So right now we have 2 Li and 2 O on the reactant side, and on the product side we have 4 Li and 2 O. So there's something wrong here. Our oxygens cancel out. We're good. Same on both sides, but our lithiums do not. So what we need to do is we need to change this coefficient of 2 for the lithium to a 4. So our balanced chemical equation for the combination of lithium oxide will be 4, 1, 2. So group 2 elements react in a similar manner, forming oxides with the formula MO, where M represents the metal. Change the color up, and we'll look here. So say we have Mg, which is a group 2 metal, alkaline earth metal, plus O2 will produce MgO. So now to balance this, we have 2 oxygens on the left, so we need 2 on the right. But this also makes us have 2 magnesiums, so we need to have 2 magnesiums on the left. So our balanced chemical equation will be 2, 1, 2. So talking about sulfur, the group 1 and group 2 elements react similarly with sulfur, forming sulfides with the formula M2S and MS respectively. So for example, we have Rb plus S8. That would produce Rb2S. And the second one, it would be BAS. Now to balance these, this could be a little tricky. We have 16 for our coefficients, 16, 1, and then 8. And for the bottom one, we will have 8, 1, 8. Now, this sulfur can be tricky. Sulfur can be represented by just S or S8. And I would specifically tell you which one to use on an assessment or another activity. So, active metals are highly reactive metals. So oxides of active metals react with water to produce metal hydroxide. So an example, we're given the word equation, we're going to make the skeleton equation and balance it. So it says we have calcium oxide reacts with water to form calcium hydroxide. All right, so we have CaO, which is a solid, reacts with, that means plus, water, which we know water is a liquid, to produce Ca parenthesis OH parenthesis 2, which is also a solid. Now, I would tell you the specific state of matter, what to put on an assessment or another activity as well. So now to balance this, we go ahead. So we have 1 calcium on the left. We have 1 calcium on the right. 2 hydrogens on the left. 2 hydrogens on the right. Now here comes our issue. We have 1 oxygen on the left and 2 on the right. So let's try to put a 2 in front of this H2O. So that would make us have 4 hydrogens. And 2 oxygens. But now we run into another problem. We have 4 hydrogens on the left and only 2 on the right. So let's put a 2 in front of this calcium. We'll go from here. Sometimes balancing chemical equations could be guess and check. So we have 2 calciums. Remember, distribute to each term in the parentheses. So we have 2 oxygens, but times 2. So we have 4 oxygens and 4 hydrogens. So what do we need to do over here? We need to put a 2 in front of the CaO. So this will then make 2Ca, 2O from the calcium oxide. Now, 2 times 2 is 4, so 4 hydrogens. And 2 times 1 is 2, so 2 more oxygens. So we have 4 oxygens total. So calciums cancel out, hydrogens cancel out, and oxygens cancel out. So our balanced chemical equation here would be 2, 2, 2, but if we reduce it, it would just be 1, 1, 1. So we really didn't need to balance that, but some good balancing practices, fine. Okay, so let's get on to decomposition reaction. So in a decomposition reaction, A single compound undergoes a reaction that produces two or more simpler substances. They are represented by the following general equation. AX will break down and produce A plus X. And just like before, AX is a compound in which we only have, in this equation, we have one reactant. And A and X can be elements or compounds. We have two products. Okay, so decomposition of binary compounds. So the decomposition of a substance by an electric current is called electrolysis. And we talked about this earlier in the year. We talked about chemical changes. So we know H2O will break down into H2 plus O2. And since it's electrolysis, electricity will be our catalyst. So to balance this, we'd have a 2 in front of the H2O, we'd have a 2 in front of the H2, and leave the 1 in front of the O2. So oxides of these less active metals, which are located in the lower center of the periodic table, decompose into their elements when heated. So for example, say we had mercury 2 oxide, HgO. And heat is present. It would be broken down into Hg plus O2. So remember to balance this, so we'll put a 2 in front of the HgO and a 2 in front of the Hg. So our coefficients read 2, 2, 1. Okay, so just some different decompositions. So the first one, we're going to do a decomposition of a metal carbonate. So we'll do calcium carbonate. All right, and since most of them decomposition will have some heat here, so it'll be broken down into CaO and CO2. Now, the definition of a metal hydroxide, we'd have calcium hydroxide. We'll have heat as our catalyst again. And broken down into CaO plus H2O. And our last one here, our last example, will be decomposition of metal chlorate. So we're going to use potassium chlorate, ClO3. And we'll change up the catalyst a little bit. We're still going to have heat, but we're also going to have manganese 4 oxide as our catalyst. So break it up into KCl plus O2. But now we need to balance this. So we're going to have the coefficients 2, 2, 3. So now, decompositions of acids. So certain acids decompose into nonmetal oxides in water. So this is very important. Nonmetal oxides in water. So an example, carbonic acid, which we know is H2CO3, is unstable and decomposes readily at room temperature to produce CO2 and H2O. So there's our decomposition of carbonic acid. And that concludes our video on combination and decomposition reactions.